All right, everyone, let's talk about solving linear inequalities. When we solving linear inequalities, it's pretty much like solving linear equation, except one important thing to remember, and this is where a lot of mistakes happen, is that if you multiply or divide an inequality by a negative number, you have to flip the inequality sign. So greater than becomes less than, and vice versa. Let's start with part A. We have negative 2x plus 6 greater or equal to 16. So it's kind of like solving in a linear equation. The first step I'm going to do is subtract 6 both sides. Right, we're trying to isolate x and all that. So the left side, positive 6 and negative 6 cancel. What remain is negative 2x greater or equal to 16. I'm sorry, not 16. 16 minus 6 will be what 10, right? Now here comes the important rule. We're about to divide both sides by negative 2, and when we do that, we need to flip the sign. So I'm going to flip the sign here just so I don't forget. On the left side, negative 2 divided by negative 2, that's just 1. So what remains is just x, and then the right side would be negative 5. So the solution is all the numbers less than or equal to negative 5. In this problem, it asks you to do two things: graph, and then use interval notation. So let me show you the graph first. So the graph looks like this. First, I'm going to draw a real number line, right? In the middle is 0. And negative 5 will be somewhere here. You don't have to do the tick marking all that. It's as long as it's in the right location. So we want anything that less than negative 5. So all the number to the left of negative 5, right? I'm going to highlight that part. So all of those there, right? Do we include negative 5? Yes, we include negative 5 because it say less than or equal to, right? So when we want to include the negative 5, because the inequality has the equal as part of it, we're going to use the bracket. I'm going to use the bracket like this. Bracket. And then for the interval notation, denote IN, is we always go from left to right. Start from left to right. So anything from negative 5 to the left. So from negative infinity to negative 5, and is bracket, right, on negative 5. At infinity or negative infinity, you always use parentheses, right? Because it's open interval. Here I can put negative infinity here, positive infinity here too. All right. Before we move on to the second problem, I want to put some notes here. Maybe use purple. I usually use purple for my note. We're gonna use, if the problem is less than, greater than or less than without the equal, we're going to use a parenthesis. That's either open parenthesis or close parenthesis. If the problem have the inequality and the equality to it, we're going to use bracket. Okay, right. And for negative infinity, positive infinity, always carries the parenthesis. Never bracket, because if you say 1 million, I say 1,000,001, right? It's never ending. All right. So let me box my answer. So those are my two answers, or one answer, but two way of expressing it. Part B, I have 3y minus 2 divided by 3 less than or equal to a quarter. To make it cleaner, I'm going to multiply both sides by 12. Why 12? Because that is the least common denominator between the two, right? And look, if I multiply both sides by 12 like this, so 12 over 1 here, I like to do 12 over 1, like that. On the left side, the 12 and the 3, Well, 12 goes into 3 4 times. So what remain is 4 here and 1 here, right? Well, 1, we don't write 1, right? So just 4 times 3y minus 2. And on the right side, well, 12, I'll use, I'm running out of color here. Maybe the light pink. 12 go into 4 3 times. 3 there, right? So less than or equal to 3. Now is inequality. You know how to solve these. First, we go into don't divide both side by 4. We run into fraction again. Distribute the 4. Right? Distribute the 4. So I have 12y minus 8 less than or equal to 3, right? And then move the negative 8 to the right, or just add 8 both sides like this. So that cancel. Now I have 12y less than or equal to 11. Divide both sides by 12. Y less than or equal to 11 over 12. Right, and then your inequality, your graph looks like this. Negative infinity, positive infinity, 0 in the middle, 11 over 12, maybe there. It doesn't have to be exact, as long as it's in the right location. It's less than or equal to 11 over 12, so to the left of 12. So anything to the left of 12. Right? Less than or equal to, we're going to use bracket. Or you can put the solid dot there. A lot of times you're going to see people put like a solid dot here, just implicating that 11 over 12 is included if a hollow dot is not included, right? And for the interval notation, it's going to be from anything from negative infinity up to 11 over 12, and we include it, so we're going to use bracket like that. Okay? That would be my answer. All right. Okay. You know that you can see the solution on decimals. Maybe I can show you that. So here, part B. Remember this part B. This is problem for part B we just did. Here is, well, I have y here. So it's going to be on the y-axis. It's less than or equal to that, right? We can check if that number is 11 over 12, because they don't give you the fraction here. 11 divided by 12. Right there, right? 0.991, because it's a y. If I put an x, it would be in this component here, the first component, and the second component. Okay. Remember the first problem we did was x is less than or equal to -5, right here. It's on the x component because x, right? There you go. Hang on. Oops, I think I have incorrect inequality. It was greater equal to, so now it's going to be less than or equal to -5. There you go. That's your solution, right? And as you can notice, decimal put the solid line here instead of dash. As you can see, this problem here we're about to do next, see is dash, because there's no equal here. So it does not, whatever the solution is, in this case was something 1.33, it does not include that value. So anything that is just to the left of that. You know, I noticed that a lot of problems here, the less than equal to or less than, I wish it was greater than. Anyway. All right, let's move on. Now part C, I have square root of 2 times quantity of x plus 2 greater than, exclusively greater than, root a times quantity of 3 minus x. Before you do anything, I recommend you, if you see root, and if you can simplify it, simplify it. Why? Because later you might be able to combine things together when it's in simplified form. So square root of 8, I can simplify it as square root of 4 times 2, which is square root of 4 times square root of 2, which is 2 root 2, right? So I'm going to rewrite this problem as root 2 times x plus 2 greater than 2 root 2 times 3 minus x. Okay, and now I can distribute those thing outside the parenthesis. So I have root 2 times x. Make sure do not write the x under the square root. Plus 2 root 2. I like to bring the 2 to the front. Greater than root 2 root 2 times 3. So the 2 times the 3 becomes 6. So 6 root 2 minus 2x. Let me put the x in the back. Variables always stay in the back like that. Okay. All right. So the next step we're going to do is that I'm going to group the non-variable terms together on the right side, and the one with the variables, I'm gonna bump it to the left side. Okay. So that means this gonna move to the right, and this gonna move to the left. How do we do that? We just do like when we solve in linear equation, right? So I'm going to subtract two both sides. Subtract two both sides. You notice that I put on the same line like that. Oops. How come I cannot? I was saving. On the left side, that cancel. And I'm gonna do it all at once. So I'm gonna add 2 root 2x. So the right side cancel plus 2 root 2x here. Cancel. So what remain is I have root 2x plus 2 root 2x greater than 6 root 2 minus 2 root 2. I know you remember, but you can combine the two together, right? If you recall, maybe I'll write it in. If I have a root n plus b root n or minus, I can combine the number in front. So a plus or minus b, and then root n. I can do that. Right, I can do that as long as you have the same square, same root, same radicand, same radical. Right? So here there's an invisible one here that we don't see. Right, so what I'm going to do, I'm going to combine them. So 1 plus 2, right there, that's 3. So 3 root 2x. 3 root 2x greater than 6 minus 2 is 4 root 2. Okay. And now we can divide both sides by 3 root 2, 3 root 2, 3 root 2. Cancel. Right. On the right side, this also cancel. That's also cancel. Root 2 divided by root 2 is just 1. So what's remain is just 4/3 on the right side. 4/3. And then on the left side, just x. Okay. So the graph looks like this. Negative infinity, positive infinity. 0 here, 4/3 there is greater than 4/3. So anything to the right of 4/3. Now we do not include 4/3. This is exclusively greater than. So maybe I'm gonna put a hollow dot here. Right? We don't include 4/3. Close to it, but not included. Interval notation is gonna be from, remember, always right is the solution from left to right. So from 4/3 to infinity. Infinity always get the parenthesis. No argue there. For the 4/3 is also get parenthesis because we don't include 4/3. Okay. Why don't you guys try part D? Maybe will be your quiz. Part D. Part E, 0x is less than 0. Does it make any sense? Any numbers, just to pick a few. Just pick it to say let's x equals something and then see what happens. If x equals -2, it's gonna 0 times -2 is gonna be 0. Is it 0 less than 0? No, it's false, right? It's false. Same thing. If you replace x with -1, 0 times -1 is still 0, and then for the left side, and then it is less than 0, it's still false, right? So any value, let's try the positive. Say 3 for x, 0 times 3 is still 0, and 0 is not less than 0. So whatever x values that you pick, this inequality is always a false statement. Right? So there's no solution. There's no solution to satisfy this inequality. So we say no solution. Right? That means no solution. The zero with the cross mean empty set, empty. It's not zero. Okay, a lot of people write thing like that is they mean zero, but it's not. Zero is a solution. Here is empty, nothing. Right? So that are your solution. Nothing. Because it's whatever x you put in is false, right? What about f? 0x greater or equal to 0. Pick a few value. You plug in negative number for x. 0 times something times maybe -5 is still 0. Is 0 always greater or equal to 0? Yes, right? Yes, it's always at least one of is always greater or equal to, right? Because there's an equal side here. That's make the whole thing. Let's make the whole thing's different than compared to part E, because it says 0 is always greater than or less or greater than or equal to 0. That is true statement, right? So whatever x you pick, that's inequality is always true. So your solution will be all real number from -infinity to +infinity because the equal sign. And then if you graph it, you can do this. Infinity, +infinity, 0 in the middle, and basically you highlight the whole number line. Right, whole number line. Okay. This last two problem is more like a critical thinking. Not just know how to solve it, know how to think as well. Right. All right, jump on application. We're gonna focus on profit, revenue, and cost. Profit is what you take home, right? Revenue is whatever you take home before subtracting the cost and the expense, right? And cost is whatever you spent. Right? So to make profit, the total revenue subtract the total cost got to be positive, right? To make some profit. Let's take a look at the example here. For a company that manufactures aquarium heaters, the combined cost for the labor and the material is about $21 per heater. Sorry, I didn't put the dollar sign there. Fixed costs are $70,000. So that's fixed cost. It's only one-time thing. If selling the price of a heater is about $35 per heater, how many must be sold for the company to earn a profit? So let's see what the total revenue is. The total revenue is going to be, before that, we need to, the question asking us is how many heater they must be sold in order to make some profit. So they're asking for how many heater. I'm gonna let x, let me write in red. This answer is always in red. Let x be the number of heater here to be sold. So the revenue will be 35x, right? Where x is the number of heaters, 35 is the cost of per heater, right? And then and so that's revenue. Subtract the cost. Let's see what cost. There's the labor and the material cost per heater will be $21, so 21x. And subtract the fixed cost as well, and then the fixed cost, 70,000, right? And this, whatever it is to be positive. Revenue subtract the total cost has to be positive, right? Or you can do it like this, but this is gonna be plus here, right? So this is your cost, and this is your revenue, right? But because I don't put the parentheses, so I just try to, subtract. And now you have an inequality that you can solve, right? 35 minus 21 will be 14x, minus 70,000, greater than 0. You add 70,000 both sides, like that. Left-hand side cancel. We have 14x greater than 70,000. And that's implied. Divide both sides by 14. So what you got, 14. 70,000 divided by 14. I have 5,000. So x is, let me turn it back to red, greater than 5,000. So they have, so they need to sell at least 5,000 heater to make some profit, start making profit. Okay. box my answer. Always box my answer. All right, number two. The variable costs occur in a fisherman depends on the level of fishing activities, and the fixed cost is normally equal to the fisherman capital value. The fixed monthly expense of a fisherman is 5,000, so that's fixed cost, 5,000 per month. The amount he spent on a fuel is the variable cost, which is 600 per ton of fish caught. The fish sells for 1,100 per ton. What is the minimum ton of fish the fisherman needs to catch to avoid occurring a loss? So again, they ask me about the amount of fish that he have to caught, right? So this is in the ton, in the number of ton. So again, whatever they ask you, let your variable be that. Let x be number of ton of fish need to be caught. Do specify your variable. You really need to specify your variable. If you don't, you have to do it at the very end, right? So for example, this problem here, if you don't have this sentence, if you don't have this sentence, then at the end you have to say the number of heater to be sold needs to be at least 5,000, right? But if you already have it in the beginning, you don't have to. Does that make sense? Okay. Let's see what is the revenue. The revenue will be 1,100x, right? 1,100x. I hope everybody clear on this. And what is the expense? The expense will be 600 per ton, so 600x minus another fixed expense will be 5,000, and this will be positive, right? To make some profit. Same thing, 500x, because you combine those two, minus 5,000 equals 0. Add 5,000 both sides. I'm going to skip that step. 5,000 here, divide both sides by 500. X is greater than 10 tons. So it has to be at least 10 tons of fish in order to avoid loss. The minimum will be 10 tons. And that's it. That is solving inequality and its application.